flight tonight, as I wrote.
Okay, sir.
And I have to prepare for that. I'm flying to Vienna for the UN meeting. Just an invite to them. Should we start now, Prexon?
Yes, sir. We can start.
Okay, let's start. Let me share the screen. So can you see my screen? Can you see my slide, Prexon?
Yes, sir. We can see.
Okay, let me start quickly and then we'll do. Welcome everyone. Sorry it took quite long. I was traveling here and there. I was in IGRAS conference in California, and then I was very busy, as you can imagine, with different proposals here. But we managed time today, and I'm flying tonight to Vienna for my United Nations high-level expert meeting on big data revolution for the planet. So that's my thing, and let's hear from you, from individuals, how you are traveling. All going good? Very quickly, let's refresh. We met one time, and then just recap how you are traveling, how you are doing with the subject, how you are doing with your work. So one by one, just 1 minute, not more than that, please. Start with Prexon. Yeah, go ahead.
Should I give the introduction or should I
Just
tell about?
how you are traveling with the subject. This subject, what we discussed is I shared with you the project, your reflection on the project, how far you are with that project. I mean, not a
Uh, I
collection or
try
discussion.
to. Yes, yes,
You
yes, sir. I try to collect some ideas for the project. I
good.
like to use machine learning uh, uh, with some for the के भन्दाखेरि अब मसिन लर्निङ युज गरेर चाहिँ मैले इन्टरपोलेसनको एउटा टेक्निकलाई युज गर्ने एउटा सोचिरहेको छु मैले चाहिँ।
Good.
त्यसमा चाहिँ अहिले कन्क्रिट आइडिया चाहिँ भएको छैन, एउटा जनरल आइडिया चाहिँ भएको छ।
Good. And you discuss this with your colleagues. You now what we have to do today is we have to form the group as well, right?
Yes, sir.
Okay, that's good.
Uh,
Uh,
we have 3 groups already
good.
in our class, uh,
So
representing 3 people.
who are the other partners for your group?
I have Vivek Tiwari and Kapil Katwal.
Good. Now let's go with then we can just you can present your group, which is good. That's okay. I learned that, and we'll discuss more that. And the other group,
Yes, sir.
Krishna Dev Singh, I see. So can you update?
So good morning. I had not अहिलेसम्म मैले ठ्याक्कै यही गर्ने भनेर ऊ गरी कम्प्लिट सोचिसकेको छैन। मैले चाहिँ रिसर्च पेपरहरू अध्ययन गर्दैछु सर। मैले 2-4 रिसर्च पेपरहरू डाउनलोड गरेको छु गुगल स्कलरबाट, मैले चाहिँ अध्ययन गरिरहेको छु।
Good. And who are the members of your group?
सुविन श्रेष्ठ एन्ड गोकुल भण्डारी सर।
They are not here. They are here?
No, they are not here.
Okay. So invite them and discuss. That's fine. And other group, Pronish, can you please update who are the group members and what is the progress you are making with the project? Pronish? Maybe he's not. You are mute. Dikpal, if you can.
सर त्यही पेपरहरू हल्का हल्का हेरेर सर के गर्ने भनेर। अब त्यस्तो खासै यो गर्ने स्पेसिफिक आइडिया चाहिँ आएको छैन।
Okay. So who are the group members?
Purnish sir and Reshmi ma'am. Reshmi miss. Purnish and Reshmi.
Reshmi. So Reshmi is not in today, right?
Hazur.
Okay. So that's fine. So let me start now. That's a good update, and we will continue this. Now let me present what we would like to talk. So we are in week 2, but we will continue week 3 very quickly. I will be back on next Friday, and then in 2 weeks' time we'll do, okay? 2-3 weeks' time. So what we want to do today is revisit an introduction to the course, flipped classroom. I want to see, when I say flipped classroom, that I want to see 1 or 2 slides, 3 slides from each of you, how you organized and things. But if you haven't prepared the slides, that's okay. We can discuss. And we talk about intermediate interpolation techniques, real-world applications, and key readings that I will provide as well. If I haven't already provided, Praxton will update me. So first part, what I would like to do is throw back on understandings and challenges faced by the students. What are your understanding on interpolation on, let's say, spatial statistics? When we talked about spatial statistics, it is a vague, it is, I would say, very broad area. But we are focusing in this subject on interpolation so that you will learn at least meaningful things in your life. When someone is asking you, can you please interpolate the data sets and create the surfaces? At least I want you to learn that, and you should be able to critical on those. What are the limitations and what are the capabilities of the method? That how we need to think, right? And as I said, I will ask you to prepare 2-3 slides on the learning outcomes and challenges to be presented in the first part. And the second part will be intermediate interpolation methods. That 2-3 slides thing we can again discuss and go bit more into detail of the data sets, the problem, the area that you would like to work on, not only technique, what is the context you would like to work on. Let's say someone would like to work on air pollution, someone would like to work on soil nutrients, someone would like to work on some other elements like geological hazards if we have the data sets. So we need to explore what are the sample data sets available, and then how we create the surface and how we can analyze those surfaces, right? So my observations, review and reflection on ILOs, think the real world scenarios in Nepalese context, right? So when you are thinking, as I said, whether it is geological hazard, whether it is a soil a nutrient type thing, whether it is air pollution, or in the surveying context, whether it is data sets of, let's say, spot heights or contours, how we can create the spot heights, sample the spot heights, and then create a continuous surface like digital elevation model. And what are the data sets we can gather for the exercise? So you need to be, as a group member, everyone should be thinking this and doing this, right? So if you look in this context, I'm not, I could have teach equations and equations in theory, but I don't want to do that. I want to make you more application oriented and practical. The theory behind it is interpolation, which you will develop or you are developing by reading the papers, right? And then it's a simple thing we are doing here. Don't aim for the very big thing, but be practical. And our context is always we need to be exploring and developing the application and practical, not the raw theory. Imagine if you are doing mathematics or statistics. I understand from my days in Kathmandu, in uh, TU or Tribhuvan University, MSc Mathematics was all about raw theorem, lemma, and things. No applications. Right? Nowadays it's changing. So here in Australia, what we do is project-based thing. Project-based is always challenging, right? And you have to manage the data sets. You have to be critical with the method. You have to think about the application, where it will apply, who are the community members in the society they will use it, whether it is surveyors, whether it is geological people, whether it is soil scientists, who are the potential user of your study. So you need to be thinking that way. In terms of delivery, if you think this way, you can write it up and it will help you to be grounded, right? So if you just learn the raw theory, what will happen is, yes, you will learn. As undergraduate students, you have to do some of the theory, but masters, you need to be thinking on applications and the practical take. Who will take it? So that sort of approach will help you to learn more. If you mean, if you compare, what I mean is learning raw is good for some basic foundation, but as a master's, as a PhD, we always think about who will use it. What is the point of doing this, right? Think that way. And then why particular data set is suitable to do the geostatistical analysis, that you need to be thinking. Let's say you want to have spot heights of certain area and you want to characterize the topography by developing DTM or DSM if it is the built up area, or DEM, right? And then you can be more critical or analytical on the product. If you are looking for hazard, then you can be critical on what would be the next step. Your recommendations should open up the eyes for the readers. And why characteristics of data is so important. When we say characteristics, what are the attributes? What are the metadata? How you can characterize, how you can dissect that data sets from different lenses, how we can go deeper. So that is the approach you will put in the project. That way, what happens is when you will be writing up, you will be recommending something based on the grounded things. You will not be just writing the things that you are not sure of. So we don't have to do the things that you can't handle. So you have to do the things, you have to be very, very practical. And I appreciate that. If in your group, if you are practical and write the report that way, what you achieve and what you couldn't achieve, right? And that's perfectly fine. My standard for you is to be honest and to be practical and to be pushing the boundary by saying what you know the knowledge now, you should push your knowledge. How you do that is by reading the papers. You don't have to swim on the papers, but you need to be very, very selective on the papers. You don't have to read more than 10 papers. Don't read that. 5 to 10 is enough, right, to do this project. And with that, you will say in your report, we adopted this particular method. And I will recommend some of the papers as well. So what were the intended learning outcomes? On successful completion of this course, you will be able to demonstrate and apply appropriate geostatistical interpolation techniques to visualize the geostatistical layers. Basically, why I'm putting this into perspective is you need to be learning in a way that how I can demonstrate and apply the technique that I'm choosing. Let's say you are choosing kriging or you are choosing simple interpolation technique, IDW, but why I'm doing that. So you need to be thinking that way and justify. You're not investigating here for the novelty. You're applying. There is a difference, right? When we do the research, then we need to be thinking on novelty. But here in the project, what you do is you need to apply the existing techniques, right? And you will compare various geostatistical interpolation techniques and relate the results to real world scenarios. And you will make some sort of appraisal on data quality issues associated with spatial data and the impact of data quality and results obtained from various geostatistical interpolation techniques. By saying that, what I mean here is we have always data quality issue, right? We can't have perfect data sets from the field. And what are those? So if you can put some sort of weaknesses of your data sets, that would be good. That will help you in your discussion. And you will incorporate cartographic, graphical, geostatistical layers and products obtained from geostatistical interpolation into the independent project report. Any questions before we start the flipped classroom? So some bouncing back of ideas, what you are thinking. We have given so much room for you. We are not every week, I'm not presenting the slides, but you have a freedom to think, to read, and choose a project and simple interpolation, either in kriging or IDW. Which one you choose, it doesn't matter. But what you have to do is you have to write in a practical sense what is the result you are getting and whether that makes sense the users, the community people, from where you are getting the data sets. Let's say you are getting a data sets from survey department and you do the work and you need to be make sure whether that is usable by survey department in any sense, right? It doesn't have to be directly implemented there, but you need to make an argument in the case it should be used from this way. So this is a project. This is not a research, but you can make an argument that though this is a project, it might be used, it might not be used, but you make a case. So with that, I would like to put a little bit of the things here, why we need mathematics and statistics to understand the associated issues. That if we haven't discussed earlier, we can discuss this. Always when we characterize the things, we need maths and stats to understand the associated issues, right? That will help us because our background in mathematics and statistics will help. And the techniques, that interpolation techniques you'll be using for real world applications, we have touched base this in the first one, but I would like to put it again here to remind you. So in mining industry, we need this. Why we need this is to quantify mineral resources and evaluate the project's economic feasibility, to decide which material is routed to the plant and which is waste using updated information as it becomes available. So think about mining. I mean, in Nepal, there are not much mining, but if you look into Australia and South Africa, for example, then there are huge mining industries and they are contributing to economy. If you look into China, how much the infrastructure requirements like different metals they are producing and exporting. Imagine the construction industry in Australia, construction industry in the USA and Europe, how much the raw materials they're getting in from China, right? So the mining, just to focus on mining. While you are planning for mining, how the interpolation will help to understand the values. I mean, it is very hard to get the right um, location values in big areas, but what we do is we apply interpolation techniques based on the sampled values. If you look into environmental sciences, this is helpful to estimate pollutant levels in order to decide if they pose a threat to environmental or human health and warrant remediation. So we discussed about air pollution, right? So imagine you have a data sets from I don't know which is the particular agency in Nepal that will look after for air pollution in Kathmandu. Maybe I don't know, you can figure out. And then you can make a case to them, look, these are the data sets for air pollution and what is the PM level, right? And that is the pollutant level in the uh, or the particulate in the air particulate, what is the pollutant level. So if you have those data sets, you can interpolate and give for whole city or whole, let's say, valley. If you have data sets from some area, let's say some central area like Singadarbar or Ratnapark or wherever, the data sets you can get, and you can interpolate that and make layers. And as we touch base on soil science, this is useful to map soil nutrient levels, nitrogen, phosphorus, potassium, and so on, to study their relationships to crop yield and prescribe precise amounts of fertilizer for each location in the field. So this is important. When we have the characterization of soil, then lots of knowledge we can get from there, right? This can be used for crop science or crop yield. Likewise, we can have, let's say, structure. If we want to develop some construction work over the soil, then we need to know the stability and geological things as well as geotechnical things. With the interpolation, we can do that. And again, it comes to variability, it comes to uncertainty, and it comes to how we map those uncertainty and variability, right? And likewise, meteorological applications to predict temperatures, rainfall, and associated variables such as acid rain. It is useful. Let's say you have temperature values from Singadarbar, you have temperature values from Ring Road, you have temperature values from the other location. But what you can do is you can create the continuous surface of those temperature for, throughout the geographical areas of Kathmandu Valley, for example. Likewise, rainfall and associated variables such as acid rain in the rainfall. In public health, if you think of how we can do in the public health environment is to predict the environmental contaminant levels and their relation to the incidence rates of cancer, right? So we have so many cancer um, addicted people nowadays, or let's say cancer disease is they are different kinds of cancer. Obviously, we are not generalizing here. But if you think of you have the data sets and you want to give some sort of knowledge to the authorities, then interpolation will help them. It is very difficult to get the data sets for each of the location. We need to go for sampling. We can't have the population for whole study area, right? So we need to have sample, and those sample will help to infer to population. Those samples will help to create continuous surface. So the readings that we will focus on week 2, key reading 2, which is performance evaluation of interpolation methods. Once we choose the interpolation methods, then we need to evaluate the performance for that particular data sets. And this reading that you will find interesting is a case study on noise mapping. So if you haven't read, um, please do that. And Prexon, can you confirm whether I already shared this reading to you?
No, sir, you
Okay,
haven't shared it.
okay, I'll do that today after this lecture. So please read this case study and noise mapping. That's the key reading that will help you. And where they compare the performance evaluation. And if you find another papers, more than happy, please find it and read it. But this will guide you how we, you know, evaluate the performance of different methods. The other reading that I will share is mathematical foundations. The exercise from section 10 and the solutions in visualizing the equations. Doing exercise by hand is really good. That I will share. And the homework is what you will be doing is you will be completing the readings for week 2. That is, as I just said, 2 readings. Week 2, key reading 2, and key reading 1 for week 1, 2. And then you need to, when we meet next time, you need to organize with the group 3 sets of data, right? For 3 groups, 1 set for each group of the 3 students. Please do it. And have a look on QG's tutorial on raster mosaic clip and sampling. That will help. And these tutorials as well. And I would share these slides too. The next lecture in about 4 nights time. But Braxton will inform you closer to the date. But what I need is your understanding, your reading on this, and dataset organizations. And you will be working on the project, and you will be submitting the report. When you have to submit the report, Braxton, can you tell me from the Kathmandu University requirement when you have to submit the reports? I mean the semester, when it will finish?
This semester should be finished by this month, Bhadra, in English, by September.
End of September, right?
Yes.
Okay, so we have 3 weeks. So you start to the project now, and then we will make sure you find the simple data sets and you work on the project following that instruction. You share the independent project requirements.
Ideas.
Yeah,
Yes.
you share that PDF file to everyone, right?
Yes, sir. We
So
can
follow
use
that.
a simple data set and simple techniques for this project.
Yeah, definitely, not a problem. So basically, what I want you to do is very practical, not research, but applied, practical. Um, find the data sets and start to work on interpolation. And if you are working for IDW and kriging, that's fine, and you can be more comparative and analytical. And as I said before, who will be using it? What are the limitations and weaknesses you found it? All that discussion you make, and then
Yes.
that's enough. It's because I understand that in Nepal, most of the lecturers they teach raw academic things in master's level as well, but that's not the way to teach. We have to change the style, and we have to go for project-based thing and grounded things. That way, student will at least learn, and we want to challenge students instead of lecturers giving everything. You have to do the things that way. You will learn, right? That's the whole idea for this subject. So, summary, the key 4 things you should remember is clear learning is effective approach. So, learn from each other. That will be much, much effective than the raw things. Iterative processes and their integration is a building block of knowledge discovery. So, it should be iterative, right? It should go back and forth among your group and across your group. The sampling strategy depends on the research question at hand, what you want to investigate, what you would like to see in your project. So that will guide your sampling strategy. An optimal approach is not necessarily the best approach, right? Sometimes, if we are after the optimal approach, that's okay, but that might not be the best. That's perfectly fine. So, by saying that, what I'm saying here is if you are compromising in collecting data sets, don't worry. Get some data sets which are valid and start to work on it, right? Don't think that, oh, this data set is not good. I shouldn't be working on it. No, don't say that. Just get the data sets and try to find the limitations, try to find the weaknesses, try to find the data quality issues, and then you write that in the report and say, this is the data cleaning process. This is the analysis ready data sets, and our group did this cleaning and identified these weaknesses, identified these limitations, identified these data quality issues. And then, as the next step, we have these analysis ready data sets by doing all that exercise, which we implemented for IDW and kriging. And here are the results. And here are the comparison. That's perfectly fine. Right? Any questions? If not, let me show you what I mean by those readings, key readings, week 2, key reading 2. Hopefully, can you see my screen as a PDF or not? I
No,
have
sir.
to change the sharing. Not yet, yeah. Okay. So stop sharing, and then I will share that window. Yeah, this one. Why can't I share? Can you see now?
Yes, sir, we can see.
Right. So this is the reading that I will send to you. What you have to do now is, yes, please organize yourself and get the data sets and report by Praxan can report me. Now the group members, these are the groups, and these 3 people will be working on these data sets and comparing IDW and kriging. That's fine. Yeah, like that, please report to me in a week or 2 times, and then we will meet how you are going with the project in 2 weeks time. And then by end of September, you will be submitting the report, and I'll be sending the marks to the department. Yeah. So this
Okay.
is what you can read: performance evaluation of IDW, kriging, and multi-quadratic interpolation methods in producing noise mapping. A case study at the city of Sparta, Turkey. Here, how they compare the IDW and kriging, and you can think of that in another data sets. Basically, this is a paper. Don't worry too much, but look in the data sets and then how they are comparing. So interpolation methods using noise mapping, inverse distance weighted IDW method. So it is explained quite well there. And the kriging, just 221 and 222, read that and understand and try to implement in your data sets. Okay? That makes sense?
Yes, sir.
And then look the discussion. That's that one. And the other one is yeah, this is, I think I shared key reading 1 for week 1 and 2. Just 2 readings you have to do. Can you see my screen? Not yet. Let me. Yeah, this is introduction to Geo Statistics. You should be able to see now. I think I shared this to you, Praxan, right? Praxan, can you confirm that you can see my screen? Introduction to Geo Statistics.
Yeah, I can see the screen, sir.
And have I
I think
shared
you
this?
have. No, sir, you haven't shared this.
Okay. So these 2 I will be sharing. And in this one, what you have to do is, if you look in here, why the variability is important. This is all about variability in stochastic methods, geostatistics, and notation. Please read the introduction, 9 pages. And then you don't have to worry much. and go to ordinary kriging only. And then in chapter 10 exercise, go to variogram here and try to do some questions by hand. So what is that? Let me show you. So this is a very good reference. Don't worry about all mathematics. See, you don't have to read chapter 2, just chapter 1. Okay, 10 pages, and then go to chapter 10. Now, those who are interested and would like to specialize in this, that's why I'm providing this. It's very advanced one. Don't try to read and understand. So, for example, this question, chapter 10, when you are doing your kriging and variogram thing, if you want to, just do this, question 1. And solution is there. And how the variability is model is there. So that question 1 will give enough idea for you. And question 2 is solution for variability again. So don't worry too much. If you come across with the variogram in the literature while you are comparing with kriging and things, you should read this. Just chapter 1 and chapter 10, 2 questions. Okay. So let's not read many things. Any questions? So we have 1, 2, 3, 4, 5, 6, 7, 8 people here, which is good. So any questions, Resmi? You were a bit late, but I understand that you have a group. So who are the group members, Resmi, for you?
Pranish, Shrestha, and Dikpal Mark.
So please, so you know what to do next 1 week, reading these 2 things that I'll say now.
Sorry,
And
sir,
then,
I couldn't hear you.
Can you hear me now?
Yes, sir.
Yes. So what I was saying is for everyone, not only for you, for next 2 weeks, you should be reading these 2 items that I'm sharing, and then you should be organizing the data set within your group.
Okay, sir.
And then reporting via Prexon that you are ready to meet with me. You have some issues in the project, like what sort of interpolation you are using, like IDW and kriging, and that discussion will be making in fortnight's time.
Okay,
For
sir.
everyone that I would like to do. So it's clear for everyone, right?
Yes, sir.
Okay, let's do that. So we have formed the group, which is great. Now we have the reading and we know the idea what to do. We want to compare IDW and kriging for everyone. But the data sets should be different. But that group will work together. And then the requirement is Prexon shared for the independent project, you will submit that. And then you will make small presentation. That's all.
Okay, sir.
And then I will
Okay,
do the
sir.
marking and send the mark. Is that
Okay,
all
sir.
right?
Yes, sir.
Yeah.
It's clear, right?
Yes, sir.
So this is a project-based subject. Please do that. Any questions, please ask. No, just one data sets for each group. So you will be working, 3 of you will be working on one data set in a group, and then you will be having meeting and you will be basically learning from each other, and you will be writing a group report. And you need to be writing in the group report who did what. That's perfectly fine. This is a teamwork. It's because the group will get same mark. One group will get, 3 members will get same mark in the group report, but in the presentation is marking criteria I put there. The group mark as well as independent mark is there. So you don't need extra data sets. So for 3 group, 3 different data sets, right? That means one group will work in one data sets. The 3 people will work on the same data sets and they write a group report. That's perfectly fine. You don't have to have an independent report. That makes sense, Pranis? Is clear? And please reread the independent project requirement and everything. So based on that, we'll do the marking and everything. Marking criteria I put there as well. So who read the independent project instructions? Everyone should read by now. You read it?
Yes, sir, we have read it.
Pranish, you read it? Good, good. Resmi, you read it?
Yes, sir.
Okay, that's good. This is a very good start. Now, as a next step, please organize the data set and meeting among yourself, the group, and then report to me via Praxon how you're going within 2 weeks. And then we'll meet and you'll write a report. It shouldn't be difficult. So, which software you are using? Do you know for IDW and for kriging? Praxon, tell
We'll,
me who
we'll
has
try to use QGIS
good, good.
or RGIS,
Yeah, RGIS, QGIS, anything you can use. Just discuss among yourself, and let's
or
try
we
to
can
get
write a Python program for that.
exactly, exactly. If you are competent and confident in Python, please do that. That's not an issue. I don't mind anything you can use. So with that, if everything is clear, so what I will do now is I will right away send these two papers to Praxon, uh, and Praxon will say to you, and Praxon will update me in 2 weeks' time, fortnight, when you would like to meet, right? How you are progressing.
Okay, sir. I'll try to communicate with my friends about the project ideas and all the materials, data sets, and I'll try to mail you when we'll have a discussion on that.
Yeah, let's do that, and then by end of September, or we can ask for 2 weeks extension for the department for a report, and then by let's say middle of October before the sign, let's send the marks to them. You submit me your report.
Okay,
Okay.
sir. Okay.
Thank you very much. You can report this to Resma about this thing, Resma madam, and that we are progressing and we are planning like this. Okay, Praxon?
Okay, okay, sir.
Thank you very much. Bye,
Thank you, sir.
everyone, and have a good time. Have a
Have
nice
a good
weekend.
travel, sir.
Thank you. Bye now.